Hello everyone, this is Pre-Calc Lesson 41, Reciprocal Trig Functions and Permutation Notation. So let's just dive right into it. Reciprocal trig functions. Okay, so our reciprocal trig functions, we have secant, cosecant, and cotangent. Secant of theta is 1 over cosine of theta. And we find it by doing the hypotenuse over the adjacent, which is the opposite of cosine, which is adjacent over hypotenuse. The cosecant of theta is 1 over the sine of theta, and this is hypotenuse over opposite. And the cotangent of theta is 1 over tangent of theta, and it is adjacent over opposite. Okay, so we are going to be doing a very similar thing with drawing our necessary reference triangles, drawing our angles, but now we're going to use secant, cosecant, and cotangent. So, for example 1, we're going to evaluate secant of 330 plus the cotangent of 480. So, let's draw 330. 330 is over here, and we know this is our 30, 60, 90 triangle, so we have root 3, 1, and 2. Secant is 1 over cosine, so the cosine of 30 is root 3 over 2. So the secant of 330 is the same thing as the secant of 30, which is 1 over the cosine of 30. So we have 1 over root 3 over 2, or 2 over root 3. We could also find it by doing the hypotenuse over the adjacent. And we rationalize our denominator, giving me 2 root 3 over 3. Now I need to do the cotangent of 480. So 480, we go all the way past 360. We go all the way over here. We have 60. Again, this is our 30, 60, 90 triangle. So the cotangent of 480 is the same thing as the cotangent of 60, which is 1 over the tangent of 60. We know the tangent of 60 is opposite over adjacent, so we have 1 over root 3, which gives me root 3. So now, here I will have 2 root 3 over 3 plus root 3. Now, cotangent of 480, we have to remember all students take calculus. In this second quadrant, tangent is negative, so this is really a negative root 3. So when we put parentheses around this, it's going to be plus a minus root 3. Or 2 root 3 over 3 minus root 3, which gives me 1/3 root 3, or root 3 over 3. Okay, now you could have left it here and done 2 over root 3 minus 1 over root 3, which would give you 1 over root 3. When you rationalize the denominator, it gives you root 3 over 3. Doesn't matter. Okay? All right, so we have root 3 over 3. Now, let's do an example with radians. We're going to have 2/3 cosecant of negative 3 pi over 4 minus the secant of 11 pi over 4. So you need to know your radians just as well as your degrees. So negative 3 pi over 4 we know puts us over here. And that relates to our 45, 45, 90 triangle, or a pi over 4, 90 triangle. Pi over 4, pi over 4, pi over 2, I guess, if you want to say it that way, which gives me 1 root 2. So the cosecant of negative 3 pi over 4 is related to the cosecant of pi over 4, which is 1 over the sine of pi over 4. We know the sine of pi over 4 is 1 over root 2, so this is 1 over root 2, which gives me root 2, and we also know all students take calculus that is negative in the third quadrant. Okay. Now let's look at the 11 pi over 4. 11 pi over 4, we know that that is going to be 1 pi over 4 short of 12 pi over 4. So we go all the way around here to here. Boop, boop. Again, we'll have pi over 4 here, so we'll have 1 root 2. So the secant of 11 pi over 4 is the same as the secant of pi over 4, which is 1 over the cosine of pi over 4, which again is 1 over root 2, which is root 2, and it is also negative. All students take calculus. So now we have 2/3 times negative root 2 minus a negative root 2. So this gives me negative 2 root 2 over 3 plus root 2, which we can write as 3 over 3, which gives me root 2 over 3. Okay, you need to be very familiar with degrees and radians. Let's do one more. Cotangent of 17 pi over 6 minus root 6 cosecant negative 9 pi over 4. All right. So, again, you need to draw your angles. Okay, we know that 17 pi over 6, we go all the way around and go to here, leaving me with pi over 6 here, which I know is 30 degrees, so I have root 3, 1, and 2. So the cotangent of 17 pi over 6 is the same thing as the cotangent of pi over 6, which is 1 over the tangent of pi over 6, which the tangent of pi over 6 is 1 over root 3. So this is 1 over root 3, which gives me root 3, and it is negative because we're in the second quadrant. And negative 9 pi over 4, we know brings me right over here. One more. Over here. Leaving me with pi over 4 here. We have 1 root 2, because you can see my 1. So the cosecant of negative 9 pi over 4 is the same thing as the cosecant of pi over 4, which is 1 over the sine of pi over 4, which is 1 over root 2, which is root 2. And all students take calculus, so it is negative in the fourth quadrant. So this gives me negative root 3 minus a negative root 2. I forgot to multiply it by root 6. We have negative root 3 minus root 6 times a negative root 2. So this gives me negative root 3 plus root 6 times root 2 gives me a 2 root 3. So this gives me a 1 root 3. Okay, now let's jump into permutations. Okay, let's look at an example. How many permutations are there of 22 things taken 6 at a time? Okay, so I'm taking 6 things, which means I'll have 6 boxes. And I'm taking 22 things, so I'll have 22, 21, 20, 19, 18, 17. And if I multiply this out, it gives me 53,721 360. Now, what we want to do is we are going to make this into a formula. So, if we write it as NPR, n things taken r at a time, right? We notice we have n times n minus 1 times n minus 2 times n minus 3, all the way up to n minus r plus 1, right? Now, what we can actually do is we can take this and make a general expression saying n permute r is n factorial over n minus r factorial. Makes it really easy, right? So let's look at this next example. Let's find 12p4. So 12p4, we get 12 factorial over 12 minus 4 factorial. So 12 factorial, I have 12 times 11 times 10 times 9 times 8 factorial over 12 minus 4 factorial is just 8 factorial, right? Which if we cancel these, I get 12 times 11 times 10 times 9 gives me 11,880, right? All we have to do is plug it into our formula. All right, so make sure you know your radians as well as you know your degrees, because we will be using radians all the time now. Completely interchangeable. And now you have a formula for permutation, which we will do more with permutations later. But for now, you may work on your other homework.